All right, this is Mr. Waterman's first flip class. We're going to get you guys to take a look at something. It'll be quick, and you can look at it on your phones, you can look at it on your computer, and there's going to be a couple questions that you need to deal with. So far we've been dealing with the surface area of 3D shapes, rectangles, squares, things like that, and we've been putting them on top of each other to make composite objects. So today we're going to be looking at the surface area of cylinders. Alright, so we're going to draw a little cylinder here. Alright, and we've got to have a height, and we have a radius. Alright, and we're going to make our radius 5 centimeters, and our height 10 centimeters. So this is kind of like a soup can, a pop can, things like that. Also, if you want to really check this out, get out some paper towel, get out a roll of paper towel, and it'll really help make some sense when you're looking at this. All right. So first, we need to do is determine the surface area of the top and the bottom, which are circles. So we know the area of a circle is pi r squared, and we're going to multiply it by 2 because we have a top and a bottom, like that. Alright, so area of our circles, we're going to go pi times 5 squared times 2. So that's 25. 5 times 5 is 25, times 2 is 50. And we get 50 times pi, and we get 157 centimeters squared. That is our top and bottom of our cylinder. Now, here's the tricky part. We're going to unravel, and this is where the toilet paper or the paper towel can really come in handy. If you pull it out, we're going to get a rectangle like this, and we're going to have 2 cylinders on the bottom. All right, and so this height we know, which is 10 centimeters, but we don't know our length, but we can figure this out. This is the circumference. Our length is the same as the circumference or distance around the circle, and so we've got a formula for that. So we can go 2 pi r or pi d. D is diameter, r is radius. Alright, so we know that. And then we're just going to multiply it by our height to get the area. So this is going to be 2 pi r, and we have to multiply it by the height to get the total area in our rectangle. Alright, so let's check this out. So we're going to go 2 pi r times h, and we're going to get 2 times pi times 5 as our radius and times our height. And all together, we're going to get 314 centimeters squared. If you multiply all those up, we're going to get 314 centimeters squared. Finally, to get the total surface area of our cylinder or can or toilet paper or whatever, we're going to add these two numbers up, 314 plus 157, and we get 471 centimeters squared. Now, that's all fine and dandy, but we need to deal with a little bit more complicated stuff. And today we're going to look at wedding cake. All right, so wedding cake is made up of a bunch of different cylinders. All right, and so what we have, and you can always go back and look at that, press stop, rewind, and go back and check out the other stuff if you went a little too quick. All right, so we've got a cylinder here, and we've got a big cylinder of a bottom of our wedding cake. And then we've got another cylinder right here, and it's the top of our wedding cake. I'm just going to make this look right. And we have something that looks like that. And just for easiness, we've got a height of 8 and a height of 4 for our top cylinder. All right. And our radius for our large cylinder is going to be 4. And our radius for our small cylinder is going to be 2. Now, we're going to label our cylinders, 1 or A and B. All right. And now we're going to determine the surface area of both of these. Now, the key idea here is that we've got some overlap. As soon as we add another shape to another shape, we've got to think about what we're taking away and what we're adding. All right. So let's do the surface area of cylinder A. So we've got to do the top and the bottom. So we've got pi r squared times 2, because we got the top and the bottom. So we got pi times 4 squared times 2, which is pi times 16 times 2. All right. All together, we get 100 centimeters squared. So that's the surface area of the top and the bottom. All right. Now we need to do the area of the side. So this is going to be A, and this is the side. And we can write top and bottom here. All right. And our side is going to be pi, or 2 pi r times h. So 2 times pi times 4 times 8. All right. Again, we unravel that toilet paper or paper towel, and we'll get that length, and that length equals our circumference, which is just the perimeter of a circle. So altogether, we get 2 times pi times 4 times 8, and we get 201 centimeters squared. All right. We're going to add these bad boys up, and we get 301 centimeters squared. That's the surface area of our bottom cylinder. Now, let's think of overlap. If we lifted off the top cylinder, we would find the overlap, and it equals the top and the bottom of cylinder A. So really, essentially, we don't need to do the top and the bottom of cylinder A. If I highlight this bottom of our large cylinder and the top of our small cylinder, it's essentially the same area as, or it is the same area as our large cylinder's top. All right, so we only need to do the side of our top cylinder. So B side, haha, and we have 2 pi r times h. So we get 2 times pi, our r is 2, and our h is 4. All right, so that's essentially saying 4 times 4 times pi, and altogether we get 50.26 centimeters squared. That's just this side part, because our overlap, we don't need to even count that. The top and the bottom are going to be, if we lifted that cylinder off, it would be taken care of. So now we're going to add these up, and we get 351.26 centimeters squared. That's the surface area of our composite 3D shape. Now, you got a couple questions to do, and you've got a couple ideas to check out. All right, good luck.